In contemporary world, you would have to work pretty hard these days to find any person who would argue when we say that our computers have become invaluable to us. In my view, and professionally, you know that our society has become highly based on the resources they offer and on sharing them with each other. The capacity to communicate with others completely hinges on the capability to create and maintain solid, dependable networks. And those vitally necessary networks come in all shapes and sizes, ranging from small and simple to humongous and super complicated. But whatever their flavor, they all want to be maintained properly, and to do that well, we need to understand networking basics. So let us begin by defining what is a network. Well, first things first, the dictionary defines the word community as a group or a system of interconnected people or things. Similarly, in the laptop world, the term network means two or extra connected computers that can share resources, such as information and applications, office machines and internet connection, or combination of these. Now you can see in photograph on the screen it shows a really primary network made up of only two host computers connected. They share sources such as file and even a printer hooked up to one of the hosts. These two hosts talk to each other the usage of a computer language called as binary code, which consists of ones and zeros in a specific order that describes precisely what they want to say. So what really is networking? Well, networking is changing the way we do enterprise and the way we live business decisions have to be made extra quickly, and the decision makers require immediate get right of entry to information. So why do we have to wait for a week to arrive with a report from Germany through postman or courier service, whereas it may want to just arrive in a mailbox instantaneously through PC networks? As you can see on the screen, we do not need to wait for a financial institution to transfer physical money, whether or not we could just transfer the cash within a fraction of seconds. So now let us dive into technical terms. Network is a set of devices connected via communication links, and a node can be a computer printer or any different device which is capable of sending or receiving data generated by means of other nodes on the network. A well-defined community must be able to meet a certain standards. Most important of these are performance, reliability, and security. So to be specific with computer technological know-how, network is a connection of two or more computers that are linked to every other in order to carry out tasks such as printing, sharing data, trade of electronic media, transferring files, copying and pasting of whatever two computers can really do. So if we try to correlate networking with our day-to-day life, we can see that a group of pals sharing ideas between the members of the group or discussing our number issues is also a network, right? It is a network of people. So community is basically defined by one element, that is, transfer of information from one point to every other or from node to other node. In the previous lectures we saw the definition of laptop networks, and in this lecture we will learn about local area network. As the title suggests, a local area network is generally restricted to spanning a particular geographical location, such as workplace building, a single department within a corporate workplace, or even a home office. Back in the day we couldn't put more than 30 workstations on the land, and we had to cope up with strict obstacles on how far those machines could without a doubt be from each other because of technological advances. All that has changed now, and we are not nearly as constrained in regard to both land size and a distance land can span. Now, the meaning of the time period workgroup in this context is slightly different than when the term is used in the domains. In this context, a workgroup is a set of units with no security association with one another. But for this course we sincerely mean they are physically in the same community segment. In a typical business environment, it is a good concept to arrange your land workgroups along branch divisions. For instance, you could create a workgroup for accounting, marketing, sales, and you can see on the Display that they have different workgroups, that is, they have under the same network segment physically. First, you don't need to comprehend about the devices that are labeled, that is switch and hub and servers. We all are going to see this in the section of networking devices. Anyway, let us get returned to the figure. Notice that there's a marketing workgroup and a sales workgroup. Now, these are nearby area networks in their most basic form. Any device that connects to the advertising land can access the resources of the marketing land, in this case the servers and the printer. But, there are two troubles with this you muse. Be physically connected to workgroup's LAN to get the sources from it. And secondly, you cannot get resources from one LAN to another. For example, the PCs from marketing can't access the servers, which are connected to the sales. And now this becomes a hassle if the sales PC wants to connect or get admission to the printer. But in our case in our figure, the printer is connected on this side of the network segment. So, what to do? Well, in the subsequent lecture we will see what is the solution to this problem. In the previous lecture we had a problem when we had been trying to access resources from one-of-a-kind network segments. Well, there is a typical network trouble that's easily resolved by the use of a cool device called as router. As you can see in the middle of the diagram, nice when trouble is solved. Well, even though you can use routers for more than just connecting the LANs, the router proven in the figure is a great solution due to the fact the host computers from the sales land can now get to the resources of the advertising land and vice versa. Now, you might be thinking that we really don't need a router, that we could just bodily connect the two workgroups with a type of a cable that would allow the advertising and marketing and the sales workgroups to hook up somehow. Well, that is also a solution. We ought to do that. But if we did, we would have only one big cumbersome workgroup as a substitute of separating workgroups for marketing and sales. And that form of arrangement just isn't sensible for today's networks. This is because, with smaller, individual but connected groups, the users on each land revel in much faster response times when getting access to the resources, and administrative tasks are a lot easier. Also, now, larger work companies run more slowly because there's a legion of hosts inside them and all are trying to get the same resources simultaneously. So the router proven in the figure, which separates the workgroups while still permitting this access between them, is really a great solution. Well, I would like to once more tell you that do not focus an awful lot on the network connectivity devices, like the hubs, routers and switches I've mentioned so a long way in this section, yet that these devices we will be all covering in the sections of networking devices. Right now I truly want you to prioritize your understanding of the concepts that I am offering here. So at this point, all you need to know is that hubs and switches are devices that join other devices together into a community. And routers connect two different network segments together. Okay, so in the subsequent lecture I will define the other terms that I have used, so a ways that is workstations, servers and hosts. So in this lecture, we will see the common network components. So the first are workstations. Workstations are often significantly powerful computers that run more than on one central processing unit, that is CPU, and whose assets are available to other users on the community to the access when they need. With this much power, you might suppose that I'm describing a server. Not quite, because there's an necessary difference between these devices that I'll be covering in the subsequent section. Workstations are often employed as systems that end customers use on a daily basis. Now, don't confuse workstations with clients due to the fact people often use the terms notebook and client interchangeably. In colloquial terms, this isn't a big deal. We all do it, but technically speaking, they are different. A consumer machine is any device on the network that solely asks for access to resources like a printer or other hosts from a server or effective workstation. Now, the terms workstation, client, and hosts can sometimes be used interchangeably. You have to keep this in mind. Computers have grown to be more and more powerful, and the phrases have become somewhat fuzzy because hosts can be clients, workstations, servers, and more. But the time period host is used to describe pretty much anything that takes an IP address. Next up is servers. Servers are additionally powerful computers. They get their name because they clearly are at the service of the network and run specialized softwares regarded as the network operating system to keep and control the network. In a good design that optimizes the network's performance, servers are rather specialized and are there to handle one important labor-intensive job. This is no longer to say that a single server can't do many jobs, but more frequently than not, you'll get better performance if you commit a server to a single task. As we all know, a client asks for resources and server provides these resources to the client. Now, we have a look at one-of-a-kind types of common servers that you may come across. First is the file server, which shops and dispenses files. Next is a mail server, the network's post office, which handles all the emailing functions. Then is the print server, which manages printers on the network. Web server manages web-based things to do by running hypertext transfer protocol, that is HTTP, for storing internet content and accessing web pages. Do now not worry, I'm going to cover all the protocols in upcoming sections. Then comes application server, which manages network applications. And lastly, proxy server, which handles duties in the place of other machines on the network, particularly in net connection. As I said, servers are usually dedicated to doing one specific essential thing within the network. It is not usually true. Sometimes they have more than one job. But whether servers are designated for greater job or single job, it is the job of network administrator to decide depending upon the necessities of the organization or the clients. And no matter what, they will all serve a number of purchaser machines, irrespective of whether a server is dedicated for a single job or multiple job. And lastly, hosts. Now, this can be difficult because when people refer to hosts, they really can be referring to nearly any type of networking devices. If you ask your friend what is a host, he may say a host is which has a laptop device which has servers and blah, blah, blah. So it is quite confusing. But if you dig a bit deeper, you'll discover that usually this term comes up when people are speaking about resources and jobs that have to do with the transmission control protocol or the Internet protocol, that is the TCP protocol. We will be having a quick section on TCP protocol in one of the sections in the courses. Now, the host means any network gadgets that has an IP address. Yes, you'll hear the IT professionals throw this term round pretty loosely, but for many certification exams, stick to the definition of being a network system which has an IP address. Now, here's a bit of background regarding hosts. The title host comes back from the Jurassic period of networking when those dinosaurs acknowledged as mainframes were the only intelligent gadgets able to roam the network. These were called hosts, whether or not they had TCP/IP functionality or not. It is not known. In that beyond the bygone age, the whole thing else in the networkscape was referred to as dumb terminals because solely the mainframe, that is hosts, were given the IP address. And from then, hosts are defined as devices which have an IP address. So in this lecture, we noticed three different terms: network components, the first being the workstations, then servers, and eventually hosts. In the next lecture, we'll see something about WAN, that is an extensive area network. Now, let us begin to an interesting lecture on extensive area network. Now, when most of the people are asked to outline the wide area network, Some of them might say it is a network covering a large geographical area, which is correct, and the rest of the people just come up with a speedy answer that is the Internet. Well, they're right. Wide area network spans a larger geographical region as compared to the local area network. With that in mind, you can think about that wide area. Networks are what we use to span great large geographic areas like 2 countries, 5 countries, or even the entire world. Like the Internet, WANs usually hire both routers than public links. So that's generally the standards that is used to define them. Now, let us have a look at some important methods that wide area networks are different from neighborhood area networks. Now, WANs usually need a router, port or ports. With that in mind, we are going to see about routers and ports in our upcoming subsequent video sections. Then, wide area networks span larger geographic areas and they can hyperlink to disparate locations. Wide area networks are usually slower than local location networks and we can choose when and how long we can connect to a WAN. Then we can make use of either private or public data transport in huge area network mechanism. For example, phone lines. Now, we all recognize that we get the word Internet from the term internetwork. An intercommunity is a type of LAN that is a local area network, or it is a kind of wide area network that connects a bunch of networks or intranets. We all recognize that when we connect multiple local vicinity networks, it forms a wide area network. In an internetwork, hosts nevertheless use hardware addresses, that is, the MAC addresses to communicate with other hosts on the local place network. However, they use logical addresses, that is IP addresses to communicate with hosts on different local vicinity networks. Routers are the devices that make this possible. Now, each connection into a router is a different logical network, located in a lot of exceptional places. Switching on to the next concept that is multi-protocol label switching. Now, MPLs will be clearly described in section 16. You don't have to fear about that. But for this section I am just giving you a brief introduction of what is intended by multi-protocol label switching. Now, it is not a service supplied by any of the devices or any of the layers, but it is an approach that is used to forward data to different a couple of destinations. Now, what is exactly MPLs? Now, I would like to read the technical definition and then I would explain in easy words using a real existence example. So the definition goes like this: MPLS is a switching mechanism that imposes labels to the data and then uses these labels to forward the information when it arrives at the network. Now, what does that mean? Don't worry. Consider this example. You are ordering a stuff from Amazon and from the center, from the data center or from the service center. They have dispatched that packaged box. They want to deliver that box to your house. So what do? Do they simply give your name? No, they give an address. They give an ID, a barcode or a QR code. So that each time the packet reaches different destinations. For example, you have ordered something from California and you are located in Boston. So from California to Boston you choose your package delivered. So the package will arrive at multiple places in between. It may arrive at Texas, then South Carolina, then New York, and then Boston. So at this joints they scan the QR code and then they calculate the next hop or the next destination. In comparable way, whenever a data is to be transferred through a network, the labels are imposed on that records packet and then accordingly the data is transferred. So this is all about multi-protocol label switching in this section. I just desired to give you a small introduction of the topic. But in section 16 we will learn more about multi-protocol label switching. Now, in the next lecture we are going to speak about peer-to-peer and client-server architecture. You might have heard these words regularly used by IT professionals. But in the next lecture I will give you a quick introduction, and I will also explain the characteristics of each types of network architectures. We have developed networking as a way to share resources and data, and how that's achieved directly maps to the unique architecture of the networking operating system that we have been using. Now, in this lecture we are going to discuss about the most common known application architecture, that is peer-to-peer architecture. There are two primary network types that you need to be aware of about. The first one is peer-to-peer and the second one is client-to-server, which you're going to see in the subsequent lecture. And by the way, it's really difficult to tell the difference just via looking at the diagram or even by checking out stay video of the network. But the differences between peer-to-peer and client-server architectures are pretty major. They are no longer just physical differences, they are logical differences too. Now, you will see what I mean in a bit. So, what is a peer-to-peer network architecture? Well, computers related together in peer-to-peer architecture do not have any central or distinct authority. They're all peers, meaning that when it comes to authority, they all equals. For example, your group of friends, right? No one has the authority to judge you or to decide who is greater. But when a trainer enters in a classroom, then teacher has your authority. That is an example of clients of architecture. Then the authority to function a security check for proper get entry to rights lies with the computer that has a desired resources being requested from it. Now, it additionally means that computers existing in a peer-to-peer community can be client machines that access resources and server machines and supply those resources to other computers. Now, peer-to-peer community architecture is perfectly fine for much less number of hosts. But if you're trying to have greater than 50 or even 100 computers in a peer-to-peer network architecture, then it turns into a tedious task. If your network is running Windows, Mac or Unix in a local region network workgroup, you have to have a peer-to-peer network. Now, when it comes to peer-to-peer architecture, security is not centrally governed. Each user has to remember and maintain a list of users and passwords on each and every machine. Worse, some of all these important passwords for the same users exchange on different machines even for accessing resources. It's a total mess. And considering that every user has to remember the usernames and passwords of different computers, a lot of memory is required in this type of architecture. For example, as you can see on the screen, this is an example of peer-to-peer community architecture. Now, Millie, Pluto, Mikey and Louie are 4 types of users. And as you can see on the screen, each consumer is storing the passwords of remaining 3 peers. Now, for example, if Pluto wants to access the sources of Mickey and Mickey has to remember the password of Pluto. This is SUCHMS. Now, this seems okay for 4 computers, however what if there are hundreds, thousands of computers? Then is it possible to store all the data in 1,000 computers of each and every peer? No, that would take up a lot of time and a lot of memory. We do now not have that much of memory just to shop usernames and passwords. And to tackle this problem, client-to-server architecture is used in today's most of the commercial enterprise applications. In the next lecture we will have a look at client-server community architecture. In the last lecture we had a look at peer-to-peer network structure, and we also discussed the disadvantages of peer-to-peer structure which we will be overcoming in client-to-server architecture. Now, let us have a look at client-to-server architecture. Client-server networks are particularly much the polar opposite of peer-to-peer networks because in them a single server makes use of network operating system for managing the complete network. So, here how it works. A client machine's request for a resource goes to the most important server which responds by handling security and directing the consumer to the desired resource. Now, this happens. Instead of the request going without delay to the machine with the desired resource, and it has some serious advantages. Now right here the server acts as a central governing authority, and that is why. There is ease of accessing the files first because the community is much better organized and does not depend on users remembering where wished resources are. It's a whole lot easier to discover the files you need because the whole thing is stored in one spot on that special server. That is why if the server is fully protected, it offers a huge amount of security to the network. Your protection also gets a lot tighter because all usernames and passwords are on that unique server, which is never ever used as a workstation. You even gain scalability. Client-server networks can have a lot of workstations on them, and surprisingly, with all those demands, the network's overall performance is actually optimized and therefore less reminiscence is needed to store the passwords. So instead of saving the 50 usernames and passwords in all the 50 machines, we can shop that only on the servers. And that is why most of the IT professionals are more involved about their servers rather than their hosts. Because in today's services, mannequin and business applications rely totally on client-server architecture to give the ease of fax access to their customers. I hope you have understand the difference between the peer-to-peer community architecture and client network architecture. I would like to stop this lecture by giving you a simple analogy. For example, if you consider you have a crew of 4 friends, and if you want to have access, or if you desire to see the assignment of your peer group, you can just ask him and he will give you his assignment. There is no one who can say no, or there is no one to preserve a watch on you. But if you have a group of 4 friends and teacher is there in the classroom, you can simply have to take the permission of the class teacher in order to do anything. Now this is the major distinction between peer-to-peer networks and client-server network, where a central authority's governing authority is there which keeps all the security measures on track. So if you have any doubts, please feel free to ask us to the question and reply portal. We will reply you as fast as you can, and again, do not forget about to please write a rating on a review for our course. It really ability a lot that you are enjoying this course. I will see you in the next lecture. Welcome to this lecture in which we are going to talk about network topology. We are going to first discuss the definition of a network topology, and then we will see the different sorts of network topology. Now, just as topographical map is a type of a map that suggests the shape of the terrain, the physical topology of a network is additionally a type of a map. It defines the specific characteristics of a community, such as where all the workstations and other devices are positioned and the precise arrangement of all the physical media such as cables. On the different hand, the logical topologies we covered earlier delineate how data strikes through the network. Now, even though these two topologies are usually a lot alike, a specific network can actually have physical and logical topologies that are very different. Now, the first topology that we are going to see is the bus topology. Now, this kind of topology is the most basic one of all the bunches of technologies, and it really does kind of resemble a bus, but more like the ones that's been in a wreck. Anyway, the bus topology consists of 2 awesome and terminated ends with each of its computers connecting to one unbroken cable running its whole length. Now, back in the day, we used to attach computers to the essential cable with wire taps, but this didn't work all, so we began the use of drop cables in the place. Now, even though all the computers on this kind of community see all the data flowing through the cable, only 1%, which the data is specifically addressed to, actually receives the data. For example, if the first PC wants to send data to the printer, solely the printer will be able to receive the data due to the fact the data is meant only for the printer and no longer for the nodes. Moreover, the bus topology is very easy to install. If you want to add a new PC, you simply have to slip a T into the main cable. anywhere if you want to join a device. Bus topology is easy to install and it's no longer very expensive, partly because it doesn't require Azure's cable as the other sorts of physical topologies. But it has some drawbacks. For instance, it is hard to troubleshoot, change or pass, and it really doesn't offer plenty in the way of fault tolerance because everything is connected to that single cable. This skill that any fault in the cable would basically bring the whole community down. Now you may be wondering, what is the definition of fault tolerance? By the way, fault tolerance is the capability of a laptop or a network system to respond to a situation automatically, often resolving it, which reduces the impact on the system. For example, if something went down, the fault tolerance will act mechanically to resolve the issue and then lower back the networks to its original position. Moving ahead now, we will have a look at the start topology. A begin topology's connections are connected to a central point with their own person cables or wireless connections. You'll often find that central spot inhabited with the aid of a device like a hub, a switch or an access point. Now do not worry about these terms such as hub and switches. We are going to see all these terms in the community devices section. Start topology offer a lot of advantages over the bus topology, making it widely used even though it obviously requires extra physical media. One of its best features is that due to the fact each computer or network section is connected to the central device individually, if the cable fails it only brings down the computer or the network segment related to the factor of failure. Now this makes the network much more fault tolerant, as nicely as a lot easier to troubleshoot. Another great thing about a begin topology is that it's a lot more scalable. All you have to do is, if you want to add to it is a new cable device, just connect the new device to central hub or the swap and you are done. As you can see on the screen, all the 6 computers are connected directly to the hub. So if you prefer to add a new computer, you just have to attach the new cable to the hub. Then begin topology is easier to troubleshoot because if one PC fails we can see that which PC is not responding, and as a result we can troubleshoot why the network is not responding. But in this case, if the central device fails, then that is a big issue. And since it is easier to troubleshoot start topology, extra fault tolerance is provided. And although it is called a start topology, it additionally looks like a bike wheel with spokes connecting to the hub in the middle of the wheel. So to sum up the start topology, this is a list of benefits you gain by means of going with it. New stations can be added or moved easily and quickly. Then a single cable failure won't carry down the entire network as it did in the case of bus topology. Then start topology is tremendously easy to troubleshoot. But there are also a couple of disadvantages to the usage of a start topology. The first one is the total installation price can be higher because if you want to add a new device, you would require new cables. And on account that if there are, let's say, 100 devices in the network, you'll want 100 different cables to connect to the hub, and consequently there is more cost. And lastly, it has a single point of failure, the hub of the central device. Now that's it for this lecture. In the subsequent lecture we will cover the ring topology and the mesh topology. In the last lecture we discussed about bus topology and famous person topology. Now let us see about ring topology. In this type of topology, each computer is immediately connected to the other computers inside the same network. Now as you can see on the screen, the network's data flows from computer to PC back to the source. The ring topology has a lot in common with the bus topology, because if you desire to add a network, you have no choice but to break the cable ring, which is probable to bring down the entire network. This is one big motive that ring topology isn't very popular. You just won't run into a lot, as I did into the 1980s and early 1990s, where this type of topology was once popular. It's also pricey because you want several cables to connect each computer. It is really hard to reconfigure. Now, let's say there are 50 PCs in the ring topology, and if you want to add a new PC, you simply have to cut one cable, and that is why it would require a lot of time, and that would bring down the entire topology. But even with that all being said, if you work at an internet provider that is ISP, you may still discover a physical ring topology in use for the technology called SONET or some different WAN technology. However, you just won't find any nearby area network having physical rings anymore. Also, when you consider that one computer goes down, ring topology is easier to troubleshoot, but as I said, it affords less fault tolerance because if one of the PCs goes down, the entire community ring goes down. Next ahead is mesh topology. Now in this type of topology you and all the 4 computer systems have their wires connected to other remaining 3 computers. Now, from this, we can sum up a formula. For every n locations or n hosts, you can have n into bracket n-1 upon 2 connections. In our case, there are 4 hosts. So let us put the price n is equal to 4 in the equation, and we can get that 4 into bracket 4 minus 1 upon 2, that is 6 connections. And you can see on the display that there are 6 wires in total. In mesh topology, there are a lot of connections. As I said, if there are 50 computers, then 50 into bracket 50 minus 1 upon 2. That is a lot of connections. Next, since there are a lot of connections, we require more range of wires, and it's a pricey topology to install. And that is why mesh topology is not a frequent topology. But if one computer fails, we can troubleshoot it quickly because that computer's cables will fail, and we are going to get to know that this PC is not working. But apart from all of the blessings and disadvantages, we can see that mesh topology provides a robust fault tolerance. Even if one PC fails, the remaining community can communicate with other PCs. Whereas in the case of ring topology, if one PC fails, the entire community goes down. And that is why hybrid mesh topology is preferred these days in the internet. In the next lecture, we will talk about any other 2 types of topologies, which is point-to-point topology and factor-to-multipoint topology. Also, we will see how to select the right topology based totally on 5 to 6 factors, which I will be determining in the next lecture. Before shifting ahead, I would like to tell you that if you are liking our lectures and if you're understanding it, we would like to request you to write an evaluation and just share your experience with us. Your motivation is very valuable to us, and if you have any issues, please feel free to type in the review and we will surely attempt to eliminate our drawbacks. I hope you will write a review, and it just takes 30 seconds. I will see you in the subsequent lecture. In this last lecture of network topologies, we are going to see 2 different sorts of topologies, that is point-to-point topology and point-to-multi-factor topology. So let us first see what is point-to-point topology. You can see the image on the left-hand facet of the screen. Just focus on that for a couple of minutes. Now, as its name implies, in a point-to-factor topology, you have a direct connection between 2 routers or switches, giving you one communication path. The routers in a point-to-point topology can be linked by using a serial cable, making it a physical network, or if they are located far aside and connected only via a circuit inside a frame relay, it's a logical network. Instead, now, the determinant on the screen illustrates 3 examples of typical T1 or wide location network point-to-point connection. What you see in the first section is a lightning bolt and a couple of round things with a bunch of arrows projecting from them. Well, the 2 round matters radiating arrows represent our network's 2 routers. That lightning bolt represents a WAN link. Now, these symbols are industry standard and I'll be the usage of them throughout this course, so it's a good thought to get used to them. Okay, so part 2 of the diagram on the left-hand side indicates two computers connected by a cable, a factor-to-point link. Now, by the way, this should remind you of something we just went over. Do you remember peer-to-peer networks that we had seen in the past of this section? I hope you remember that. Good. Now, I hope you also remember that a huge drawback to peer-to-peer network sharing is that it's now not very scalable. Now, with this thing in mind, you probably won't be at all amazed that even if both the machines have a wireless point-to-factor connection, this network still won't be scalable. You'll normally find point-to-point networks inside many of today's wide area networks. And as you can see in the phase 3 of the diagram on the left-hand side, a link from a computer to a hub or a swap is also a valid point-to-factor connection. A common version of this setup consists of a direct wireless hyperlink between two wireless bridges. Now just focus on the determinant that is on the right-hand side of the screen, that is point-to-point, that is factor-to-multipoint topology. Again, as the name suggests, a point-to-multipoint topology consists of a succession of connections between an interface on one router and multiple destinations as router. One point of connection to multiple factors of connection. Now, each of the routers then every one of the interfaces involved in the factor-to-point connection are part of the same network. The discern on the right-hand side shows a huge area network and demonstrates a point-to-multi-factor network. You clearly see a cable corporate router connecting to multiple routers, the department offices. That and the figure on the left-hand side are the two different kinds of topologies that you need to remember. Now, a hybrid topology is a topology that is a combination of two or more bodily or logical network topologies working together within the equal network. Now, how to select the right topology? Now, you can just ask the question, well, you are simply connecting cables between two hosts, so why do we need to actually think over this point? Wrong. Regardless of the kind of the network you build, you need to start questioning about the quality at the bottom and work up. Now, I will give you an actual life example and make sure you pay attention to it. Think of it as if you were at an electronics store buying the cable for your domestic theater system. You have already spent a bunch of time and money getting the right components to meet your needs. Now, due to the fact you've probably parted with a hefty chunk of change, you might be tempted to reduce corners. But why would you stop now and connect all your high-best devices together with the cable equivalent of twin? No, you are smarter than that. You recognize that picking out the exact cables that will maximize the sound and the picture exceptional of your specific components can also shield them, right? It is the same thing when you are faced with deciding on the physical media for a specific network. As you know, not solely you have a buffet of network topologies to choose from, but everyone has its pros and cons before implementing it. But it sincerely comes down to that well-known advantage: ask the right questions. How lots cache do you have? How much fault tolerance and security do you definitely need? Also, is this network likely to grow like a weed? Will you want to quickly and easily reconfigure often? In other words, how scalable does your community need to be? For instance, if your challenge is to design a great cost-effective solution that includes only a few computers in the room, getting a wireless get-right of entry to point and some wireless network playing cards is definitely your best way to go, because you might not need to part with the cache for a bunch of cabling and it really is super easy to set up. Fault tolerance of the topology. Now, if you have around 10 to 15 computer systems and you select ring topology, then that's a bad call. Ring topology offers a least fault tolerance. So before selecting the right topology, you want to ask the question of fault tolerance. And finally, security requirements. Now, these 5 elements you should always consider earlier than you select the right topology for your network. That's it for folks. This is all for the network topologies, and I hope you are mastering a great content from this course. And there you go. Finally, we have completed the first area of this wonderful networking course. This section created a solid basis for you to build your networking knowledge on, and as you go through this course, in it, you realized what exactly a network is, and you got an introduction to some of the factors involved in building the routers, the switches, and as well as the jobs they do in the network. You additionally learned that the components required to build a network aren't all you need. Understanding the various types of community connection methods like peer-to-peer and client-server architecture is additionally important. Further, we learned about the various types of logical and bodily network topologies and the features and the drawbacks of each of them topology. I have wrapped up the root with a short discussion about the network diagrams and segments, and I additionally told you how to select the right topology to make sure that you come up with the right network for your networking needs. Now, what do you need to bear in mind from this section? First of all, know the names and descriptions of the topologies. Be aware of the differences between every physical networks, that is what humans see, and the logical networks, what the equipments see. Then it is important to recognize what each topology brings to the table, and knowing the various traits of each topology comes in handy during the troubleshooting. Then you want to understand what WOU, LD you use a LAN, and when would you use a wide area network. A LAN is used to join a group of hosts together, and a WAN is used to connect various neighborhood area networks together. Now ending on this, up ahead is a small quick check for you to test your knowledge of this section. Make sure you apprehend the lectures correctly, because until and except you compete with these foundational terms, you won't be able to understand the subsequent course. So make sure you understand each concept. And if you haven't understand, please feel free to ask in the Q&A, a portal. You would be happy to reply you as fast as possible. Last but not the least, if you are truly enjoying this course, please recommend this route to all your friends. And do not forget to check the sources sections, where we have added new interesting video hyperlinks to our YouTube channel so that you get a strong foundational knowledge of all the concepts. And don't neglect to rate our course. Your feedback is very valuable to us. I will see you in the subsequent section of this course. Let's start a brand new area, that is, Open Systems Interconnection Model, that is the OSI model. Now in this section, we are going to analyze the Open Systems Interconnection Model. I'll thoroughly describe each section to you in detail because it's very necessary for you to grasp the OSI model key concepts. Once solidly equipped with this crucial foundation, you'll be set to move on and build your personal storehouse of networking knowledge. The OSM model has several hierarchical layers that have been developed to enable different networks to communicate reliably between disparate systems. Now, due to the fact our course is centering upon all the things in network examinations, it is crucial for you to understand the OSI model as CCNA, CompTIA, or Juniper certifications see it. So in that way, I'll current each of its 7 layers in that light so that you can clear all those assessments with fine colors. I'll also provide you with an introduction to encapsulation in the similarly part of the course we'll not be covering in this section. Now, encapsulation is the system of encoding data as it goes down to the OSI stack. Now, let us talk about inter-networking models. In the very first networks, the computers concerned could communicate only with different computers made by the same manufacturer. For example, businesses ran either a complete DESE net answer or an IBM solution, but they were not in a position to run both together. In the late 1970s, the Open Systems Interconnection, that is the OSI reference model, was created by the International Organization for Standardization. It's now not iOS, it's ISO. To break through this barrier, the OSI mannequin was meant to help providers to create interoperable network devices and software in the structure of protocols or standards so that different vendors' networks should become compatible and work together. Now, like the world peace, it probably in no way happened completely, but it's nevertheless a great goal to achieve. The OSI model is the predominant architecture model for networks. It describes how data and community information are communicated from an application on one computer via the network media to an application on another computer. The OSI reference mannequin breaks this approach into different layers. Now, let's move on and discover this layered approach as well as how you can utilize its key standards to troubleshoot in the networks. Now, let us describe what exactly layered approach means. Basically, a reference model is a conceptual blueprint of how communications have to take place. It addresses all the processes required for effective communication and divides these techniques into logical groupings called layers. When a communication system is designed in this manner, it is known as layered architecture. Think of it like this. Say you and some friends want to begin a company. Now, one of the first things you will do is to sit down and think via what tasks must be done, who will do them, the order in which they will be done, and how they relate to each other. Ultimately, you may group these tasks into departments. Let's say you decide to have a patron service department, an inventory department, and a shipping department. Each of your branch has its own unique tasks, keeping its workforce members busy and requiring them to focus only on their very own duties. Now, in this scenario, I am using departments as a metaphor for the layers in the communication system. For things to run smoothly, the group of workers of each department has to trust and count heavily on the others to do their jobs and competently handle their special responsibilities. During your planning sessions, you'll probably take notes, recording the entire manner to facilitate later discussions about standards and operation that will serve your business as a blueprint or a reference model. ONC. Your business is launched, every department leader will need to improve practical methods to implement their assigned duties using the specific part of the enterprise models. Now, these practical methods or protocols must be compiled into a general operating procedures manually and followed closely. The techniques in your manual will have been included for different motives and have varying degrees of importance and implementation. If you shape a partnership or acquire another company, it will be crucial for its commercial enterprise protocols to either match or be compatible with yours. Similarly, software program developers can use a reference model to understand PC communication processes and see exactly what have to be accomplished on any one layer and how. In other words, if I need to increase a protocol for a certain layer, I only need to center of attention on that specific layer's functions. I don't need to be involved with those any of other layers because distinctive protocols will be in place to meet the different layer needs. The technical term for this thinking is known as binding. The communication processes that are related to every other are bound and grouped together at a specific layer. Now, let us have a look at the advantages of a reference model. The OSI model is hierarchical mannequin, and I'd like to point out that same beneficial traits can actually apply to any layered model. Understand that the central purpose of the OSI mannequin and all networking models is to allow different providers' networks to interoperate smoothly. The first advantage being the OSI model divides the network conversation process into smaller and simpler components. Thus, it aids component development, design, and troubleshooting. It additionally allows multiple vendor improvement through standardization of network components. Third, it encourages industry standardization through defining the specific functions that can occur at every layer of the model. Next, it allows various types of community hardware and software to communicate. Finally, it prevents changes in one layer from affecting other layers and setting apart the development and making application programming much easier. Now, this used to be all for this lecture. In the next lecture, we'll see what exactly the OSI reference mannequin is. Let us finally start with the OSI reference model. One of the greatest features of the OSI specifications is to assist in data switch between disparate hosts, regardless if they're Linux, Windows or Mac OS. But keep in mind that the OSI model is not a physical model. It's a conceptual, logical and comprehensive, yet fluid set of guidelines which software developers utilize to create and implement functions that run on a network. It also provides a framework for creating and imposing networking standards, devices, and in the networking schemes. The OSI model has 7 layers. First is the application layer, which is responsible for file, print, message, etc. Next is the presentation layer. The 5th layer is the classes layer. 4th layer is the transport layer. The 3rd layer is the network layer. The 2nd layer is the records link layer, and the 1st layer at the bottom of the OSI reference model is the bodily layer. Well, we'll now see the functions of each of these layers. The OSI's 7 layers are divided into 2 groups. The pinnacle 3 layers define the rules of how the applications working within the host machines talk with each other as well as with the quit users. The bottom 4 layers define how the authentic data is transmitted from end to end. Now, the first layer being the application layer. Application layer gives a user interface and is responsible for file, print, UI. That is user interface, messages, email, database, and different services. The next is the presentation layer. Now, presentation layer is responsible for presenting the records to the application layer. It handles processing such as data encryption, compression, and other translational services. The subsequent layer is the sessions layer, which keeps different applications facts separate. It is responsible for keeping the sessions of special windows altogether different. The 4th layer is the transport layer. Transport layer provides reliable or unreliable delivery. Then it performs error correction earlier than retransmission of data, which means it provides end-to-stop encryption right from the sender to the receiver. Then being the network layer. Now, network layer offers logical addressing which routers use for path determination. It employs IP addressing, subnetting, and routing. Don't worry, we are going to look after all of these terms in our upcoming sections of this high-quality course. The second last layer being the data hyperlink layer. Data link layer combines packets into bytes and bytes into frames. It provides access to media the usage of MAC address and it performs error detection and not error correction. This is one of the most important MCQs at some stage in your placements or your questions. Whether data link provides error detection or error correction, the right answer is data link layer gives only error detection. It does not correct the error. The closing layer is the physical layer which moves bits between devices. It specifies voltage, then it specifies wire speed and pinout of cables. For example, the real physical data transfer via LAN cable happens at the physical layer of the application. If you look at the photo on the screen, it is clear that actual users interact with the laptop at the application layer. It's also apparent that the top layers are responsible for application S communicating between hosts. Remember that none of the higher layers know anything about networking or network addresses, and that is why in the Until Now lecture, I had told you a property of isolation of layers. That's the responsibility of 4 backside layers, the networking addresses, everything is the responsibility of transport, network, data link, and the bodily layers. The image also illustrates that 4 backside layers define how data is transferred through the bodily media, switches, and routers. These bottom layers also determine how to rebuild a statistics stream from transmitting hosts to a destination host's application. Okay, now this was all for this lecture. In the subsequent lecture onwards, we will see each and every layer of the OSI model in a very designated way. We will start our next lecture with the application layer. Before shifting ahead, I would like to tell you that if you haven't rated our course, I request you to please leave a ranking to our course because it motivates us. It just takes 30 seconds to do. You can see a superstar in the right-hand corner of your screen and you simply have to click that and leave a rating. That's it. We expect from you. You have to assist us if you want more courses from our side. I will see you in the subsequent lecture. Let us begin with the application layer, that is the first layer from the top of the OSI model. Well, the software layer of the OSI model marks the spot where users simply communicate or interact with the computer. Technically, users speak with the network stack through application processes, interface, or APIs that join the application in use to the operating system of the computer. The software layer chooses and determines the availability of communicating partners along with the sources necessary to make their required connections. It coordinates partnering applications and forms a consensus on processes for controlling data integrity and error recovery. Resources for the requested communication exists. Now these tasks are essential because computer applications on occasion require more than just desktop resources. Often they unite speaking components from more than one network. Application prime examples are file switch and email, as well as enabling remote access. Network management, purchaser server processes like printing and information location. Many network functions provide services for communication over organization networks. But for the present and future internetworking, the need is fast growing to reach beyond the limitations of modern physical networking. Now, it's important to have in mind that the application layer acts as an interface between application programs. For instance, we all have been using Microsoft Office for a lengthy time and every one of us know what actually Microsoft Word is, right? So Microsoft Word would not reside at the application layer. It just interfaces with the software layer protocols. Now, what are those protocols, how those protocols are used to transfer facts and all those things we are going to see in our next lectures. But for time being, keep in mind that application layer acts as the interface between the application program and the decreased layers of the OSI model. In the next lecture, we will talk about the presentation layer of the OSI model. Now let us talk about the presentation layer, which is the second layer from top of the OSI model. The presentation layer gets its name from its purpose. It provides data to the application layer and is responsible for records translation and code formatting. A successful data transfer method is to adapt the data into a standard format earlier than transmission. The presentation layer ensures that data transfer is understood by the software layer. Now, computers are configured to receive this generically formatted data and then convert again into its native format for reading. For example, from EBCDIC to ASCII is the work that is done by the presentation layer. The OSAP has protocol requirements that define how should be formatted in tasks like statistics compression, decompression, encryption and decryption are all associated with this layer. Some presentation layer standards are even involved in multimedia operations. Now we will talk about the sessions layer. The session layer is responsible for placing up, managing and then tearing down sessions between presentation layer entities. This layer also provides talk control between devices and nodes. It coordinates communication between structures and serves to organize their communication by imparting three different modes: simplex communication, half-duplex communication and full duplex communication. To sum up, the periods layer basically keeps data separate from functions data. A good example is a session layer allows more than one web browser sessions on your desktop at the equal time. In the next lecture we'll talk about the transport layer. Now let us speak something about the transport layer. Well, the transport layer segments and reassembles data into a data stream. Services positioned in the transport layer handle data from the upper layer functions and unite it onto the same data stream. They provide quit-to-end data services and can set up a logical connection between the sending host and the destination host on an internetwork. The transport layer is responsible for providing the mechanisms for multiplexing higher layer applications, establishing virtual connections, and tearing down virtual circuits. It additionally hides the many and sundry details of many network-dependent data from higher layers. Transport layer is the home for transmission control protocol, that is TCP, and the user datagram protocol, that is the UDP. We will see all of these protocols in our upcoming sections. Do no longer worry about that. But if you're already familiar with them, you be aware of that they both work at the transport layer. You also know that TCP is a dependable service and UDP is not. Now, in the next lecture, we are going to talk about what is a connection much less service and what is a connection-oriented service. The transport layer can be connectionless or connection-oriented, but it's particularly important for you to really understand the connection-oriented component of the transport layer. So now let's take some time to delve into the connection-oriented protocol of the transport layer. In the last lecture, I told you about transport layer and I also instructed you the two protocols that worked at the transport layer. But before diving deep into the protocols that actually work at the transport layer, you first want to know the difference between the connection-less protocol and connection-oriented protocol or services. Now, earlier than transmitting host starts to send segments down the model, the sender's TCP program contracts a destination's TCP technique to establish a connection. Well, the resulting creation is regarded as a virtual circuit. It's like before, you have to call your friend. You establish a connection through the cable lines, and then you establish a path through which the fax packets may be sent that forms a digital circuit. And this type of communication is called as connection-oriented communication. Now, all through this initial handshake, the two TCP processes also agree on the quantity of information that will be sent in either route before the respective recipient's TCP sends back an acknowledgement. So before certainly transmitting the data, both the source and the destination agree on a sure amount of data that is to be sent and obtained next. Such type of communication that is connected-oriented carrier is always reliable communication due to the fact for sending the data, a fixed path is present and it makes it warranty that these packets will be delivered at the destination. Now, you have two computers on your screen. It depicts a typical reliable session-taking region between sending and receiving systems. Both of the host's application programs begin by way of notifying their individual operating system that a connection is about to be initiated. The two running systems communicate by sending messages over the network, confirming that the switch is approved and both the sites are equipped for it to take place. After all of it is done, the synchronization occurs, a connection is fully established, and the data transfer begins. This digital circuit setup is called as overhead. So what you are currently seeing on the screen, it is a setup for a connection-oriented session and it is called as overhead. While the statistics is being transferred between the hosts, the two machines periodically check in with each other whether or not the communicating through the protocol software is going on nicely and that data is being received properly. So, to sum up the steps in the connection-oriented process, it is known as a three-way handshake, that you would have a certainly clear picture of how it works. You can refer to this as the three-way handshake, as I already mentioned, known as SYN, ACK and ACK, or synchronize acknowledgement and acknowledgement. Now that sounds relatively simple, but things don't usually flow so well. Sometimes concession can occur during a statistics transfer, because a high-paced computer is generating data site visitors a lot faster than a network can handle transferring it. Now, what is connectionless service? Well, it is precisely opposite of the connection-oriented service. It has less overhead. It does not require any time for circuit setup. As we had already discussed, whilst in the case of connection-oriented service, there is a path that is established before the conversation actually happens. A time is allotted for that path to set up. Whereas in the case of connectionless service, that time is now not required. Next, it is not reliable communication. Well, how can it be? It does not structure a specific path for the transfer of the fax packets. Whereas in the case of connection-oriented services, a specific dedicated path is shaped first before transmitting the data. Then connectionless service is prone to community concessions. Now, since there is not a dedicated course to this, the packets can reach the destination at whatever course available in the network. The data packets are prone to community concessions. Now, in the next lecture, we will see another new interesting idea known as flow control, which is also employed at the transport layer. Now I would like you to introduce a new thought which is known as flow control. In the last lecture, we noticed the three-way handshake and we thought that this is the basic process and after this records will get transferred. But that is not the case every time. Sometimes congestion can occur throughout a transfer because a high-velocity computer is generating data site visitors at a lot faster speed than the network can take care of transferring it. A bunch of computers simultaneously sending datagrams through a single gateway or to a destination can also clock things up. In the latter case, a gateway or vacation spot can become congested even though no single source motive the problem. Either way, the problem is like a freeway bottleneck, too much visitors for too small a capacity. It's not usually one car it's a problem. It's that there are just too many cars on that particular route. Now, drift control. Data integrity is ensured at the transport layer by maintaining flow, manipulate, and by allowing users to request dependable data transport between systems. Flow control provides a capability for the receiver to govern the amount of data sent via the sender. It prevents sending a host on one side of the connection from overflowing the buffers in the receiving host, and even it can result in data loss. Now, dependable data transport employs a connection-oriented communication session between systems and the protocols worried in the insurer. Now, what is a buffer? Basically, buffer is a memory section for storing data, minutes. So what occurs when the machine receives a flood of datagrams too quickly for it to process? It shops them in buffer. But this buffering tactic can only solve the problem if the information gram are a part of the small burst. If not, and the datagram deluge continues, a device's memory will subsequently be exhausted. Its flood capacity will exceed and it will react by discarding any additional fax grams that arrive like a dam spilling over. This sounds pretty bad, and it would be if it weren't for the transport function community to control that can actually work really well. Well, segments are sequenced again into the proper order after the data is transmitted from source to destination. Now you can see an image on the screen that is demonstrating the data transfer between the sender and the receiver. Instead of simply dumping resources and allowing data to be lost, the transport can problem a not ready indicator to the sender or source as shown on the screen. For example, the sender is transmitting the data, the receiver tells that, "Hey man, please stop. My buffer is full." I'm not ready to accept the data. Hence it sends a message, not ready, please stop. Then, at the receiver side, the fax gets processed and finally the message is sent, hey man, I'm ready to go. And again, the sender starts off evolved sending the data. This process is known as the flow. Manipulate process in which a specific flow is made, aimed between the sender and the receiver so that the records is not discarded in an invalid way. To summarize, a service is considered connection-oriented if it has the following characteristics. We'll study it one by one. You just have to listen and pay interest to it. First, it uses a virtual circuit to set up as we had seen in the case of the three-way handshake and connection-oriented carrier where a virtual path used to be established between the sender and the receiver. Next, it uses sequencing, it uses acknowledgements. Acknowledgement is a message announcing that you have received the data. For example, giving you a real-life instance of acknowledgement is whenever a teacher says, do you want to reply this question? You either reply yes or no. That is an acknowledgement. And finally, connection-oriented service should have a flow control, which we have just seen in this lecture. In the subsequent lecture, we'll talk about windowing, what a window is, and how windowing helps in achieving the most success ratio while transferring data from the sender to the receiver. Another important time period in the transport layer is windowing. We already saw, in the last lecture, what flow manipulate is and what acknowledge means. Okay, enough for this video. Thank you for stay with me till the end of the video. Keep cool and stay anonymous.